So here's some definitions that we use, the kind of like algebra definitions. So it's lingo that we'll use to get a little bit of a introduction of algebra so that we can be able to better use different formulas in different ways when we do geometry and trigonometry. So a lot of this that we're doing right now, it's kind of generic math, I'd like to call it, but we kind of have to know how to do these steps to be able to do our more complicated geometry and trigonometry we'll do and work with formulas more. So when we say variable, we're talking about an unknown number represented by a letter, typically. So there's a, kind of the more algebra ones we use n, x, like with proportions, we're using those sometimes. The ones that we'll use after we get this introduction are for radius, circumference. This I wanted to throw in a Greek letter. Sometimes we'll see those every once in a while. This is one that's used to denote an angle sometimes. A lot of times we use capital A for an angle, but we might see that thrown in there. So capital A could be for angle or area, W for width, D for diameter or dimension. It just depending on the context, rather than having to write a whole word, we throw in a variable. If there's a number in front of the variable, it means it's multiplied by it. Okay, so like I have an example here, but something we've seen before, like for perimeter, 2L plus 2W. That means 2 times the length plus 2 times the width. Okay, so if we know, like in this example, 3n, and we know that n is 2, we would do 3 times 2 and we'd get 6. Or if n is 10, 3n would be 3 times 10, 30. Okay, now if I use the word term, term is the variable and the coefficient together. So like in that last example, 3n, the whole thing is called a term. And then a constant term is if I have a term with no variable. So 4x plus 2, 2 is the constant term. Because no matter what x is, if x is 5 or if x is 10 or x is -2, whatever is happening in this variable part, we're always doing plus 2, plus 2, plus 2. That never changes, it's constant. Now, when we have the variables and we have coefficients, terms, all of that, and then we throw in an equal sign, we call it an equation. So like I wrote 2L plus 2W up above, but when I put P equals 2L plus 2W, we call that an equation. Or a formula is just an equation that's a common calculation used all the time. So probably, one of the most common would be perimeter, or like area being length times width. That's one we've used before. A equals LW, or L times W. So same thing if I have two variables right next to each other. It means multiplication between them. So that's some of the lingo we're going to use. Now, we're going to pretty much for the rest of this unit, we're going to be solving equations, solving formulas. So let's look at the first few steps of that. So when I have x plus 2 is 7. So we're going to first just kind of think about this. What plus 2 gets me 7? So if we think about what plus 2 is 7, the only thing that it could be, I'm going to leave some space, but it's got to be 5. 5 plus 2 is the only way I'm going to get 7. Okay, so we're just trying to figure out, like, what is this number in that spot? Now, the step to go from x plus 2 equals 7 to x equals 5, though, how do we get there? Because what if it's not something I can just think of off the top of my head, like it's a decimal or there's negatives? So what I would do is, since this is x plus 7, I'm going to, x plus 2, I'm going to subtract 2. Because 2 minus 2 is 0. So it's like it cancels it on the left side, but I have to do the same thing to the right side. Whatever you do to one side, you have to do the other. So if I subtract 2, think of it like a scale. If I take 2 off of this side, I have to take 2 out of this side to keep it equal, to keep it balanced. So that's how we get that 5. So what did we do to get x alone here? We subtracted. Okay, versus the next one now, it's a subtraction problem. X minus 3 is 6. What minus 3 gets me 6? 9. 9 minus 3 is the only way I'm going to have that be true. Okay, so the way I get from the equation to the answer, since it's subtracting 3, I'm going to add 3 to both sides. Because minus 3 and plus 3 is 0. And I'm just left with x then on the left side, but I have to do the same thing to the right. 6 plus 3 is 9. So what did we do here to get x alone? It's a subtraction problem, and we added. Okay, so think of the subtracting and adding. These are opposite operations. So we do the opposite operations to get to our answer. So whatever is being done to x, or if we want to move something to the other side. Okay, how about here? 4b equals 20. So again, if it's just 4b, this means 4 times b equals 20. So 4 times what is 20? It's 5. 4 times 5 is 20. That's the only thing that's going to be true for b. So to get from each of those steps, since it's 4 times b, I'm going to divide. 4 divided by 4 is 1, which 1b, 1 times anything is just itself, so we don't really need that 1 in front anymore then. So whatever, if we have something multiplied by the variable and we want to move that thing, we can divide it to the other side. So whatever, if I divide by 4 on the left side, I have to divide by 4 on the right. 20 divided by 4 is 5. So this was a multiplication problem, and I did division to get b alone. Okay, now the last one. What divided by 5 is 6? What can go on top here to divide by 5 to get 6? The only thing that's going to work is 30. 30 divided by 5 is 6. Okay, so to get rid of that 5, since this is x divided by 5, I have to do the opposite operation and multiply. Okay, and just kind of like fractions we've done, can cancel that out. Put that 5 over 1, the 5s will cancel. I'll be just left with x equals 6 times 5, because I have to do times 5 on the other side. X is 30. So whenever it's x divided by something, do the opposite of division, opposite operation of division, and multiply. Okay, so now let's do a couple, keeping in mind we're going to do the opposite operation where maybe I wouldn't just off the top of my head know the answer. So 4.5 plus a is 7. So to get a alone, I'm going to subtract 4.5. So a is by itself. 7 minus 4.5. If I want to do this by hand, let's make it 6 2/2. So 2.5. So now I've got some negatives, which makes it a little tricky sometimes. -4 equals x minus 6. I'm going to add 6 to both sides to get x alone, because -6 plus 6, that'll cancel. Now I can do -4 plus 6. A -4 and a +6 will be a +2. Keep in mind too with these, if I want to do a check, I know I didn't do it for the first one, but do it for the first one too. If I want to make sure that -4 is 2 minus 6, 2 and -6 is -4, yep. So the two sides should be equal. Okay, now this one, 1.7n equals 1.2. Remember, this means times. So if I want to move the 1.7 to the other side, I want it to cancel on the left side. So since this is times, then I'm going to divide by 1.7. Whatever you do to one side, you have to do the other. So 1.2 divided by 1.7. That's when I need my calculator for sure. And we'll go to the hundredths since I didn't really say how to round. About 0.70588, so about 0.71. Okay, and now a division one. N divided by -3 is 11. Since this is divided by -3, I'm going to do the opposite of division and multiply. Notice how the sign doesn't change. We're not changing the sign, it's changing the operation to move it to the other side. So multiply by -3 on both sides. 11 times -3 is -33. I'm going to check this one. -33 divided by -3. Yep, that would be 11. Because a negative divided by negative is positive. 33 divided by 3. Yep, that would be 11. Okay, so to summarize a lot of the ideas we kind of talked about, the goal is we're trying to get the variable alone, and we're going to do the opposite operation being done to the variable. Operation. So we're not changing the sign, we're changing the operation. And whatever we do to one side, we do to the other. Okay, so there's a website here. You got the PowerPoint and Blackboard. You can click on that and see. This shows like a scale and the idea about getting the two sides of an equation balanced. Check that out if you want a little more explanation.